Good afternoon, everyone. We'll be starting class in 1 to 2 minutes time. Alright, good afternoon, everyone. And today's tutorial session is going to be focused on practicing analyzing code snippets for figuring out their space and time complexity. In particular, most of the questions that you tend to be asked in programming interviews focus heavily on finding the time complexity of particular pieces of code instead of the space complexity. But it's also kind of important to also know about the space complexity, especially when you're dealing with recursive functions, so that way you know and have a general idea how your memory is going to expand as your recursive function grows and keeps on calling itself, to see what's the efficiency of it. So let's get started. So this lecture in particular is going to be showing different examples of code here, and for each example I'm going to give you some time to figure out what's going to be the complexity. I'll set up a poll for each one of them, and once you figure out what the complexity is and you vote accordingly within the time frame, afterwards we'll see how the votes are split to see who got the correct answer, who gets the wrong answers, and so forth. And I'll explain to you guys afterwards what is the correct answer and how do we determine this correct answer and so forth. After this tutorial session, you will get all the answers on my learning for each one of these sessions. But however, as I kept on stated in previous lectures, the final answer is likely with 1 mark. The approach is what's going to carry most of the marks throughout solving these problems in particular. Alright, so we have our first example here, and from Monday's lectures we saw some previous examples where we could determine what's going to be the complexity by following certain trends regarding for loops and recursive functions and so forth. So I'm going to give you guys about let's say 3 to 4 minutes, and I'm going to set up a poll here and see if you guys can figure out what actually is going to be the complexity of this particular piece of code. And afterwards we'll figure out how the votes lie from the poll, and then we'll go about explaining why we got this particular answer for this particular piece of code. Set up the poll here. Right, and our poll is set. Should be coming in the chat now. Right, so like I said, I'm going to give you guys 3 to 4 minutes to figure this out, and once you figure it out, put your votes in the poll, and then we go out with the explanations once the poll closes. Alright, 30 more seconds until the poll closes. Right, the poll has closed, so let's see what the results are going to be once it pops up here in the chat. Alright, so the majority of people who voted, they voted for O of n, as a few people voted for O of 1, O of n squared, and a very minority voted for O log of n. So the correct answer here is actually O of n. And let's go about seeing why this is O of n. So this instruction here is just a singular instruction. So that's like 1, that's 1. This loop here, we see that it starts at 0 and it goes up to the array length. And if we treat array length as n, for this particular instruction here, that means that instruction runs n times. So for this particular loop, this is O of n. And then for this loop as well, if we watch this particular instruction here, This also starts at 0 and goes up to array length, so that is also going up to n. So this also is O of n. And because they are loops that are following each other and they're not nested, comes like if we add the two of them. So it's like if we get 2 O of n, and we don't really care about any of these dominant terms and so forth. So we don't care about this 2 here. We only care about what's going to be the nature of our complexity, if it's linear, if it's quadratic, and so forth. So that's how we end up here with O of n accordingly. Are there any particular questions regarding the explanation for example 1? Feel free to ask now. Yes, O of n basically means that it is linear in nature. So the O notation here, the big O notation just basically describes the behavior of the code where it expands linearly, quadratically, logarithmically, and so forth with respect to n. Because all we care about is the nature of how the code will expand as the size of n increases. So in this case, we treat n as our array length. So we would just want to know what's going to be the behavior of the code as it expands with regards to time. If it's going to be a linear expansion for time, if it's going to be a quadratic expansion with time, and so forth, and we just specify that mathematically in terms of big O notation, so that's just going to be O of n. If it was nested loops, as you saw in Monday's lecture, those multiply together instead of adding. So remember, in Monday's lecture, it's particular coming down to the end of the second lecture, we saw an example for nested loops in particular. And we also saw the example for when loops follow one another and they're not nested. So when they're following one another and they're not nested, they just add together. But when they are nested, they multiply together. Alright, doesn't seem like we have any further questions. Let's move on to example 2 in the meantime. So let's set up the poll for this. I'll give you guys 3 to 4 minutes to figure out what's going to be the complexity for this. And 30 seconds again for the poll. Right, closing the poll now. Let's see what the results are here. Pops up in the chat. Alright, nice. So the majority of you guys voted for O of n squared, which is the correct answer. But we still had some people with thinking it's O of 1 or O of n. Thankfully, no one thought it was O log of n. So let's explain why was this O n squared. So wait, let's go back here. Right. So we got O of n squared here as our result. And the reason for this being here is because these loops are nested instead of following one another. So same thing like before, if we treat the array length here as our n variable, for this particular loop it'll run n times, and for this particular loop this will run n times as well. And let me just erase this here for a little bit. This will run n times here as well. And because they basically are nested, that means we have to wait for when all the iterations here for the innermost loop needs to be completed first for this outermost loop here to just register one iteration. So it's like saying if we had two loops and they're going up to 3 in particular, we can call this L1 here and L2 here. And L1 is the outer loop, and L2 here is the inner loop. What happens here for each iteration, so we can say this here is at 0, and they're going up to 3, so it'll be 0, 1, then, sorry, 0, 0, 0, 1, 0, 2, 0, 3. And then when it hits 3 here, that's because the innermost loop has finished all its iterations. The outermost loop counts 1, and then it reiterates back through the innermost loop and keeps on repeating. So it'll go 1, 0, 1, 1, 1, 2, 1, 3, then it'll go 2, 0, 2, 1, and so forth as it keeps on going. So that's how nested loops basically end up multiplying their orders together in particular, because the outermost loop only counts for 1 when all the iterations of the innermost loop has been completed, and then only when the outermost loop has finished all its iterations, both loops will basically finish executing at that point. And if you check that, being that if this was 3 here, and this was 3 here, you basically get that 9 iterations, which is 3 by 3. So that's how we get the order O of n squared, because this one here is n, and this one here is also n, so just multiply the two, O of n squared. Alright, any particular questions regarding example 2 here? It doesn't seem like we got any more questions. Oh, okay, maybe got one. Yes, it should be 0, 1, 2, but basically you get the gist of what I'm getting at. Basically, they just keep on counting going up. So we will have this line here, have this line, and so forth. But it's just basically the gist of what I was saying. You'll see that we end up getting 9 iterations total if there were 3 for their real link. Alright, so let's ask example 2 here, but in a different fashion, and let's see if you guys can actually figure this out regarding it. So I'm going to ask you guys the same particular time complexity question for example 2 here, but in this particular case, pops up, we are going to be specifying a value here for our array length. And because we specify the value here for the array length, is the order going to be the same or does the order changes? Let's see what you guys think. This is going to be like a bonus round, like a bonus quick question, so you're going to get like 1 to 2 minutes to vote on this. I have 30 seconds again for this poll. Right. Okay, so let's see what the results look like, huh? Okay, so there was a sort of a little bit of confusion here regarding this. I mean, the majority of you did get your answer correct, which is O to the 1. But there were some people who were still thinking it was O of n squared. Some people who thought it was like O of n and O log of n. So the reason why it's going to be O to the 1 here in particular, it's because when the array length is 1 here, right? Grab my laser pointer. Right. So when the array length here is 1, for each one of these loops, because it's just 0 and then less than 1, these loops only execute once. They don't execute any more than once regardless. So because each one of these loops execute once, this comes like just a single line of code that doesn't repeatedly execute itself. So this would just be like, this executes once, this executes once, this executes once, and because it's just one time these lines are executed, the order of the entire system here, or this entire piece of code, is just going to be O of 1. If it was repeatedly executing, then it would be a little bit different, where we actually did do the multiplications and so forth. But if, let's say for instance, if this array length here was a different value from this array length here, then we will have 2 different orders being multiplied by each. We'll see a particular example of that later on in this lecture, if not in next week's morning lecture when we have these kinds of situations. What's going to be the order in that particular case? So let's go on to example 3 in the meantime. So example 3 is going to be a little bit different, and let's see if you guys can actually figure out what's going to be the order in this particular case. Okay. I'll give you guys 3 to 4 minutes to answer accordingly. You can figure out what the order is going to be here for example 3. Remember guys, J here starts differently for this particular example. That's going to be a key difference from the previous 2 examples that we just observed. Right, 30 seconds again for voting. Right, let's close off our poll here and see what the results look like. Alright, so we had a huge disparity here with our results here for example 3, where only like 2/5 of the class thought it was O of n squared, and then the remaining 3/5 of the class thought it was a variety of different answers here. So the majority here is also correct. This is going to be O of n squared, but the question basically asks you, how do we derive this runtime? And like I keep on stressing, that is what's going to be carrying most marks. And you have to be able to explain how did you derive these runtimes in particular in order to get these marks here. Got an incoming question here. Yes, basically that's what you're doing. So you're going to be looking at the start of the array, the total size of the array, and based off of that information, you're going to figure out if it's going to be multiplied or add, depending on the structure of the loops, if they are nested or not. So let's go about the explanation here for why this is going to be O of n squared, and you want to see how we went about getting this. So when we start at, okay, wait, before I do that, remember we're going to be treating our array length here as n, and then let's watch what happens here when we start our loops, right? So at I is equal to 0, j here is I plus 1, so that here is going to be 1, and this goes up to n, and this also goes up to n. So from 0 to n here for I, we know that's these iterates n times, right? What we're going to be concerned about here is how does this inner loop here apply for this j equals to I plus 1 in these particular cases, right? Similarly, if we also watch when I is equal to 1, j here is I plus 1, which is 2, and both of these also go up to n as well. So this here will be like first iter of I, and this here will be second iter of I. Right? So that's what we're watching here in particular. Now, because we know in each particular case j here is going to be equal to I plus 1, let's rewrite this in terms of I. So I here will be equal to j minus 1, right? And because you know j here was basically going up to n, in this particular case, when we watch this for the innermost loop here in particular, and we start deriving our explanations for this, so the first time j runs, it's going to be, let's just erase this for a little bit here, a little bit of space. So the first time j here is going to run, it's going to be n minus 1, oops, wrong casing. It'll be n minus 1 steps. And then the second time j runs, it's going to be n minus 2 steps. So that means the third time and the fourth time it's going to be n minus 3 and n minus 4 accordingly as we keep on going up in values, right? So what that means here is that for each one of those iterations, taking the I loop into consideration here for each time the j loop is going to be executed, that means that the total number of steps, go back here, 1, right? So our total number of steps will be n minus 1 plus n minus 2 plus n minus 3 plus dot 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 plus 3 plus 2 plus 1. And that formula looks very familiar, doesn't it? Isn't that formula the same thing as sum of 1 to n minus 1? And if you can recall what that looks like, when you do your arithmetic progression regarding this, this was n into n minus 1 divided by 2. And if you expand that out, you see you'll get an n squared term here. As of such, that order here is going to be O of n squared. So if we just expand this out, I'm going on the top left hand corner here just to expand it. This will be n squared minus n divided by 2. And we drop the non-dominant terms. So basically, we get n squared here as our order. So that's how we get O of n squared here accordingly. So that line of reasoning is what you're going to be using in particular to figure out how do you derive your runtimes accordingly. And that's where most of your marks is going to be concerned with regarding how do you derive these runtimes. So any particular questions regarding example 3 here? Yeah, you basically have to state it like how I did, showing step by step how did you end up deriving the runtimes here. Just putting the answer isn't enough, because you still need to explain how did you get that answer. So, like I said, the answer is just going to be like, if this was a 5-mark question, the answer will just be 1 mark. The remaining explanation here will be the 4 marks. We drop the non-dominant terms. So remember, n squared here will take precedence over the n in this particular case, because we care about the order, not the specifics. So the most dominant term here would be the overall order of the entire piece of code. That's an arithmetic progression formula for sum of digits from 1 to n. So you can always find arithmetic progression formulas regarding summations or repeated stuff and whatnot. There's also geometric progression formulas as well, which is basically like a very handy way of figuring out how can you sum from 1 to n instead of doing it manually, or how can you do some repeated calculations where something changes by 1 all the time. It's a mathematical notation for finding a formula to represent this entire summation series. So the name for it, I'm typing it in for the chat. It's an arithmetic progression. And there's also one known as a geometric progression for multiplication. All right, any further questions? Yes, you do, but at the same time, you don't actually have to like go back and learn the entire thing from scratch because most of the times you're going to be having these tools at your fingertips online. So once you basically have an idea how the arithmetic progression or the geometric progression works, it's possible for you to just, once you have the basic knowledge, you can just reapply it or find a tool that will automatically apply for you online, if you're to go about doing this. However, when you're going to the interview, you're not going to have any online presence. So it's kind of important that you do know the base knowledge regarding the arithmetic progression and geometric progression regardless. So yes, for deriving runtimes, you need to know what either one is going to do. Yep. Alright, so let's move on to example 4 in the interest of time here. Alright, so one thing I want you guys to pay attention to here, regards to example 4, is how do these loops operate in particular. So I'm going to set up the poll here. And take your time trying to figure out this one. I'm going to give you guys about 5 minutes to figure out what is going to be the answer in this. Right, poll should be active in a few seconds. The tips and better understand this material is really just to keep on practicing problems regarding time complexity. There's no other way to get around this. So I did give you guys some general ideas how to go about deriving the complexities, in particular in Monday's second lecture. So that's a good starting point for how do you go about deriving the complexity to different types of situations. But in order to get experience with deriving it, you're actually going to have to keep on practicing altogether. And there are several different tutorials online, several different analyses online that you can do with time complexity of code. In particular, like if you're using LeetCode or Hacker Earth, any one of those websites, there is a certain section where you can actually go and test yourselves for analyzing complexity of code in particular. So the only way to get better at this in particular is you just have to keep on practicing, and you have to observe where you make the mistakes and make sure that you don't repeat these mistakes while attempting these problems throughout any sort of code analysis that you're doing. One more minute for voting. Thirty seconds. Alright, closing off the poll now. Alright, let's see what these results look like. Alright, so the majority of you guys voted order of A by B, which is the correct answer, but we had some people thinking that it would have been O of A or O of B, and then some other people thought it was O of N squared, and a very few thought it was O of 1. So let's go about this explanation in particular. Alright, so the hint that was stated on the slide here is that you have to start with the innermost statement and work outwards. So this if statement here, that is going to execute only once. Alright, so because we know that's going to execute once, we don't have to watch about it anymore regarding this. Let's work with the next statement, because we're going innermost to outer. We're going to see here that J starts at 0, but J has array B length. And we say, okay, that's fine. And then if we could jump one more to go to the outermost loop, the I here is 0, and I is array A.length, which is fine as well. But we were not given any explicit relationship between array A and array B. If their lengths are same, or if their lengths are different, or if there's some mathematical notation between the two. So, because there's no explicit relationship stated here between the lengths of array A and array B, that means these variables for A and B need to be independent of one another. So that means that we have to say array A length is treated as A, and array B length is treated as B. And because we're treating these now as A and B instead of terms of n, because we don't have any explicit relationship between array A and array B, the standard rules apply that for nested loops, the orders just basically multiply with one another. So for this here, this is going to be O of B, and this here, this will be O of A. And that just multiplies with each other, so O of A by O of B will give us order O of AB. So this holds true because we did not have that explicit relationship between array A and array B and what its length is going to be. Let's say, for instance, if we knew that array A dot length was equal to array B dot length. In that case, because both of them have the same length, we can just assign this to one singular variable, in this case n. And in that particular case, it'll be O of n squared. But that's only because we have some inner workings or some knowledge of the arrays themselves. If we don't, we must treat them as independent variables. So that's why we end up getting an A variable and a B variable for array A and array B with regards to their lengths. And then we just apply the standard rules for nested loops, that the orders just multiply with one another. So that's how we got order of A multiplied by B, or order A by B. Right, any particular questions regarding this? It doesn't seem like we have any questions, so let's go on to our last example for today. And let's see if you guys can figure out what's the order for this last particular example. Set up the poll here. Yes, the code that executes once, we don't really care about it because it only executes once. We want to be looking at what the loops do in particular. In here. Right. So I'm submitting the poll here for this last example. And let's see how you guys vote. Because this last example is somewhat similar to the previous example, I'm only going to give you guys about 3 to 4 minutes to figure out what's the answer in this particular case. If it's executing more time with respect to A or B in some sort of fashion, then we do care. But if it's not with respect to A or B in this particular fashion, we kind of don't really care. Because well, so long as there's no relationship between A and B, it's treated as its own independent variable altogether. And you'll see why this is particularly true for this particular example. All right, 1 more minute for voting. All right, closing off the poll now. All right, so I'm glad to see no one thought it was O of 1 or O of n squared in this particular case. But we still had some people think it was O of A or O of B. So the correct answer here was the majority vote as well, which was O of A multiplied by B. And let's explain why this was this answer and for this in particular. Right? So for this here, let's go 1, 10. We do the same thing as before, where we start with the innermost loop and we go to the outermost. So this statement runs once. This loop here, we see that it goes up to a constant of 100,000. So you might say, okay, that runs 100,000 times, but because it's a constant, we treat that as O of 1. And that's basically because no matter what, that loop will always execute 100,000 times, no matter what. Not affected by A, it's not affected by B. So it's basically a constant, and we treat that as an order of 1 for any sort of constant value that we are dealing with. For the next loop in our sequence here, oops, right, we start at j equals 0, j goes up to array b length, so we can say array b dot length has its own variable b, so that's going to be order of b. And then for the next loop here, I starts at 0 and I goes to array a length, so array a dot length can be treated as its own variable a because arrays a and b have no explicit nature that was given to us. So this here is going to be order of a. And the loops here are nested, so that means these orders multiply with one another. That's order of A by order of B by order of 1, which is going to be order of AB as required. So the only trick to this question was that the innermost loop here had a constant value at which it runs up to. So no matter what happens for array A and array B, this innermost loop here for k will always execute 100,000 times no matter what. And because it's always going to be executing at this constant amount of time, no matter what, that's treated as a constant, and the order for any constant is going to be order of 1. And same thing like from example 4, there's no explicit relationship between array A and array B, so we treat these as independent variables. So this one is going to be order of B, this one will be order of A, and because the loops here are nested, they just multiply with one another, and it's O of A by O of B by O of 1, which just gives us O of A by B. Alright, so we are basically out of time at this point, so if there are any further questions, feel free to leave them down in the comments below, or you can directly email me. In Monday's session, we're going to be doing more examples regarding analyzing the code and figuring out what's going to be space and time complexities in particular. So try not to miss out on Monday's session. At this point, you need to be heading over to Akash's session in Blackwell Collaborates for your software engineering lectures, if I believe that's correct. So head over there, and until Monday, take care, be safe, and I will see you guys soon. Later.